power and resistance, there are two other electrical units we need to consider. One is power. When a current passes through a device, the electrons transfer some of their electrical energy to it. We see bulbs light up, motors spin, and a radio will make a sound. To make the bulb brighter, the motor spins faster or the radio louder. The energy has to be transferred more quickly. To deliver the energy more rapidly, we can use a battery or power supply with higher voltage. This will increase the rate at which the electrons move around the circuit. In other words, we increase the current in the circuit. Power is a measure of how quickly the device transfers the energy we deliver to it. As the bulb gets brighter, the motor spins faster and radio gets louder, we say they are using more power and working harder. A powerful device is transferring a great deal of energy each second. Working out the power transferred. Power is watts. Another term is potential difference. Volts times current, and we use the letter V for volts and I for current. So the power equals volts times current. The PD tells us how much energy each electron has, and the current tells us how many electrons are arriving each second to transfer their energy. Multiplying V and I, or power and current, tells us how much energy is arriving and how quickly it is being transferred. It tells us the power being used by the device. We measure power in a unit called a watt. A 1 watt bulb transfers 1 unit of energy every second to heat and light. A 1 kilowatt kettle will take twice as long to boil a 2 kilowatt kettle if they both have the same amount of water. Examples of power calculations are shown in the table below. Table 3.1. So have a good look at this. Pause the video and you can see there. So power equals volts times current. So there's an example. 3 volts times 0.3 is 9, and so on and so on. So have a look. You'll get an idea of how this is calculated. Table 3.1. Examples of power calculations.